Welcome to the day 7. Today we're going to talk about operators in Java. Different types of operator, logical, comparator, mathematical, all the different types of operators which is possible. See, in the real world also, I always say that you go and tell your relatives who loves you more, which is bigger, which is smaller. So in the world of programming also, many of the times you would like to do some kind of logical comparison, you would like to do some mathematical comparisons, and all of that is available in Java and almost all programming language. How do we do it in Java? We'll see in this video. Let's get started. Now let's get started with the Java unitary operator. There are different types of operators in Java, right? In the conditional we saw that using the operators we have been able to find the Boolean things. Many times in the real world also we need to compare different things, which is hotter, who loves you more, who cares for you more, I need this one or that one, this is smaller, this is bigger, this is giving me the higher salary. So we end up doing comparisons day in and day out. If the real world problems has to be solved in the world of the programming, we need to facilitate that comparison in the world of the Java as well. And for that there's a good support of operators. Just like other programming language, Java has a very smooth support for different types of operators. What are those? Let's get started with the example itself. So what I'm going to do now is that let me go and define a new class and let me go and call it as operators, learning operators. Let me go and call it as learning operators. Perfect. So I have created this class called as learning operators, and inside this class learning operators, let's first get started with, let me first of all go and define the public static void main. I'm writing it all the time again and again because I want you people to get used to this term. What it is we'll still reveal in our upcoming videos. So public static void main, anything that we need to go and write which has to be executed should be inside this method, which is public static void main. Now let's say that I have something called as int x equals to 10. Now let's assume that I want to go and increment the value of x by 1. How can I do it? It's very simple, no? I can go and say that x is equal to x plus 1. This is a simple way of doing it. And now if I go and do the sys out and print x, what the value should go and print? If I go and run this, it should print a value called as 11. Fair enough. Let me go and write it as x equals to plus plus x. And if I go and run this again, run as Java application, the output is same as 11. Now when I go and write x equal to plus plus x, what that means is that I am trying to increment the value of x. X's initial value is 10. I'm just trying to go and add plus 1 into this. This has become equals to 11, and this 11 is getting assigned to the value of x, so it is able to print 11 itself. Now instead of doing the plus plus x, there's another way to increment it, and that way of incrementing is you go and write that x equals to x plus plus. Now if I go and run this, can you guys tell me what should be the output? Can you guys make a guess? Pause the video, don't Google search. Can you tell me that what should be the output here itself? If I go and run this, the value is still coming as 10 itself. I have this value 10, and when I go and run this, this still value as 10 itself. What has happened? What is the difference between x plus plus x and x plus plus? What is the difference? It's a very important interview question. Most of the people ask you. In the plus plus x, we first increment and then assign it to, so basically, in other words, I can go and say that if I have, if we go and write it again, if it is x plus plus or minus plus plus x, what is the difference? In the x plus plus, what happens is that you first use x, whatever the value of the use x is it, and then increment. Whereas in this case, I first increment and then use. So for example, in this case, when I did plus plus x, x value was 10. So in this case, first I increment, so it became equals to 11, and then I use. So this x value was printing 11. Whereas in this case, I first use the x value here is 10 only. So first I go and make use of x, so x has become 10, and then this value got incremented to 11. So since x value is still 10, so it is printing 10 itself. So plus, so any value that you do I plus plus or plus plus I, the difference between these two is that in this first increment, because increment is in the left, so first increment happens and then you go and assign that value to the I. And in the first case, first you have the value of I and then you go and increment that. That's how this works. Make sense? Fair enough? Cool. The similar operation you can go and do for the minus also. So let's say that if I have int y equals to 20, and if I go and write SOUT, let's say that I go and say that y equals to minus minus y, and I go and print it says out y. What should be the value that should get printed here? Let me go and comment this out, the previous code. If I go and run this, it will go and print 19. But if it was y minus minus, what should go and print? It should go and return me the same value, because it first get assigned to the y and then it was decremented. So it is returning the same value as 20. Fair enough? Now since we have understood plus plus and minus minus operator, let me ask you a few logical questions around that. So let me first comment this whole code out so that it doesn't get executed all the time. Let me bring it down and then you guys tell me what should be the answer. So if I go and say that int x is equals to 10, and I go and write ss out, and I go and say that x plus 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 x plus plus. If I go and run this, can you guys tell me what should be the output of this? Let's try to run this and see what happens. And you guys let me know if your answer is correct. Now why it is 21? Let's try to see that. So this value is 10. This value is 10, right? And then I have this value and I have this value. You go and start doing the operation left to the right. When I do x plus plus, this value got incremented to 11. Then you do plus, and then from here you only get the value of 10. So it gets multiplied 11 plus 10 and the value comes out as 21. You always do the operation left to the right. X plus plus got incremented, it became 11. Then you added a plus icon and then x plus plus. This value got used first and then it was incremented later. So this is only 10, this is 11, so it is 21. Fair enough. If instead of this, if I go and use this expression, if I go and say that says out, and I go and say that plus plus x plus 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 x, what should be on output? Can you guys make a guess here? Let's try to save this and run this file. In this case, the answer is 27. How is that? How is the answer 27? So what happened here is the value was 10 here. The value was 10 here. This, and after this would have executed, the value of x would have become how much? The value of x would have become 11, right? Plus when it got added, right, the value of this x was 10 itself, right? And when it got added, its value became out as 21. So this is how I got printed, right? But when this also got executed, the value of the x would have became equals to how much? It would have became equals to 12, right? And when I do here, the value of this will become equals to 13, and then this value will become equals to 14. So when 13 and 14 got added, the answer becomes equals to 27. If you're not able to understand this, please pause the video, go back and watch this That's the advantage of this recorded videos that we are giving you. It can do it in the self-paced as many parts as possible. So this is one of the tricky things that I want you guys to take care of with the x plus plus and plus plus x icons. Fair enough. Now since we have understood this, let's try to move to the next concept. The next concept is another type of the operator. Let me go and comment this out first and then move to the next type of the operator. Alright, so this is the next type of the operator, and here the next type of the operator that we have is tilde. Okay. So this operator which you are seeing, this is used for the Boolean, right? So if it is true, if I go and apply here, this will become false. Let's try to see that in action. So for example, if I go and write sys out and I print true, right, and I run this is printing right now true itself. But if I want to put a tilde, this negation before that exclamatory sign and run this again, the value turns out to be false. If it is false, then it will turn out to be true. Let's try to run this. This turns out to be true. Fair enough. Now let's talk about the tilde itself, right? So let me go and say that sys out, and I go and say that tilde 10. If I go and run this, let's first of all run and then I'll explain you how this works. It is returning -11. So what it says that whenever there is a positive number, if it is a positive number, which is a positive number, and I have to do the tilde of that, how do we find it? So we go and see that from the 0 till 10 there are how many digits? From 0 to 10 there are 11 digits, and we go and just put the minus sign before this, so the answer is -11. Let me give you 4 more examples. You guys tell me what should be the answer here. So if I go and comment this out and ask you that sys out, and I go and put the value as tilde 15. What should the answer? Can you guys make a guess? If I go and run this, the value will be -16. How? Because what I'll do is that I'll have to go and, since it's a positive number, I go and set from 0 till 15. That how many numbers? That's 16 numbers, and so answer will be -16. Now what happens in the case of the negative number? Let's say that if I have to go and do the tilde for a negative number, right? So I go and say that sys out, and I go and say tilde of -10. If I go and run this, the answer turned out to be 9. How does that happen? So in order to get if it is a negative number, which is 10, what I need to do, I have to start from the 0 and I have to keep on moving 10 times. So this is one time, 0, 1, 2, 3, 4, and like when I'm 10th time, this number will be the 9. So the value is equals to 9 itself. So this is how this tilde operator works. Once we have done that, let's try to move to the next type of the operator. The next type of the operator, which not very common in Java, but still I think we should know it. And again, maybe the interviews, the people can ask you this question. Let's try to see that what that question is. So these type of the operators are called as the left shift or right shift operators. Okay. So basically, let's try to see that. Sys out, and I go and say that 10, and 10 has to be left shifted once, right? So this operator which you see is called as a left shift, and this is an example of a binary operator. This is an example of a binary operator. Why binary operator? Because when I go and do this, I will first convert this into the binary number and then apply it, and then apply left shift. Because how will you go and shift a decimal number? It has to be in a binary, for it has to be shifted. So first of all, let's try to see this. Let's try to see a pattern. If I go and run this, when I left shifted 10, it became 20, right? If I do further, make it twice, make it thrice, and I run this again, you will see a pattern. Every time I'm shifting it more, this is getting twice. So 10 left shift once, it has become 20. If I left shift 2, it has become 40. If I left 3, it has become 80. So every time I left swipe, every single left swipe, what it does, it makes the number double. Right? So initially the value was 10, first left swipe it became 20, second left swipe became 40, third left swipe became 80. So every time you left swipe by a number, this becomes doubled that many times. Now how has that happened? Let's try to understand that how this is giving me the number as 20. So 10, if I have to go and convert the 10 into the binary number, right, it should be 1, 2, 4, 8, 1, 0, 1, 0. So basically 10 could be represented in the binary form as 1, 0, 1, 0. If you don't know how to convert a decimal number into the binary number and vice versa, I will suggest you people to take a pause, go do a Google search. It's very basic mathematics. I want you people to understand that how the binary number could be converted to the decimal number and how the decimal could be converted to the binary number, vice versa. So 10 could be computed in the binary in the form of 1, 0, 1, 0. Now if I have to do the left shift 1, it means that all characters have to move by 1. Right? So if the all character moves to the left by the 1, it becomes equals to 1, 0, 1, 0, 0. This is the number which comes up. Now if this binary number has to be converted into the numerical value, so I can go and say that 0 into 2 to the power 0 plus 0 into 2 to the power 1 plus 1 into 2 to the power 2 plus 0 into 2 to the power 3 plus 1 into 2 to the power 4. Now this value becomes 16 plus 4, which is equals to 20, and hence I am getting the value as 20. Fair enough? Similarly, if I have to go and explain you the second part, right, 10 is represented as 1, 0, 1, 0. Now if I go and left shift twice, so this becomes equal to 1, 0, 1, 0, 0, 0. This is the binary number. Now if I have to convert that into the decimal number, this becomes equals to 0 into 2 to the power 0 plus 0 into 2 to the power 1 plus 0 into 2 to the power 2 plus 1 into 2 to the power 3 plus 0 into 2 to the power 4 plus 1 into 2 to the power 5. This value turns out to be 32. Everything is 0. This value turns out to be 8, and then all of these is 0. This turns out to be 40. So this is how the left shift operator works. Similarly, if I go and do the right shift, right, for example, if I go and do the right shift, says out, and I go and say that 100, and I go and do the right shift once. So left shift is making it twice, right shift should make it half. Let's try to run and see if it works. It is coming out at 50. If I go and do this 2 further, it should make the value as 25. So normally whenever in your problem statement, especially in the data structures and algorithm, and you have to write the efficient code, if you have to double something or if you have to half something, typically make use of the left shift and the right shift, and it will actually optimize your operation, because then this operation happens at the byte level itself. Fair enough. So now since we have understood the left shift and the right shift operator, let's try to talk about the other types of the operators, right? So the very commonly used types of operator are called as the comparators operators. Let me go and talk about those. Let's say that there are sys out, right? So I can go and say that 4 is less than 5, right? So this is 1. The other could be 4 is less than equals to 5, or you can have greater than equals to 5, or you can have greater than equals to 5. or you can have the equality operator, or you can have the not equals to operator. So these are the different operators that you have. Let's go and run this. So if I go and run this, run as, right, these are different types of the operators that you have. Now apart from all of these, there's another type which is called as the AND operator, right? So when I go and talk about the AND operators, it is again of two types, logical AND and another is bitwise AND. Logical AND is represented by double ampersand in the world of the Java, and bitwise AND is represented by the single ampersand. Now both have the different results. Let's try to see that. Now AND means that if the first condition is true and the second condition is true, then only the answer will be true. If one of that is false, then answer will always be false. Or if both of them, then obviously the answer will be the false itself, right? That's how it looks like. So now what I go and do here is I go and say that sys out, and I go and say that 1 is less than 2 and 4 is less than 5. If I go and run this, this will be true. Let's change another condition. 1 is greater than 2 and 4 is less than 5. If I go and run this, this will turn out to be false. If both are false, 4 is also greater than 5, then also the answer should be the false itself. This is called as the logical AND, right? This is called as the logical AND. Now let's talk about the bitwise AND. So let's say that I go and say that sys out, and I go and say that 3 and 5. Let's run this and see what happens in that case. If you're going to write 3 and 5, the answer turns out to be 1. Can you guys tell me how the answer is 1? Because this bitwise works on the bits. So first of all, I have to go and convert 3. So if I go and convert into 3, this will be 1 1, right? So the 3 will be represented as 1 1, and if I have to go and represent 5, 5 1 2 4, so it will be 1 1 0 1, right? So I have 3 which is represented by 0 1 1, and then I have 5 which is represented by 1 0 1, and when I go and put AND, it will try to compare AND. So both is 1, so this becomes 1. This is 1 and this is 0, so this is turned out to be 0. This is 0 and this is 1, so this turns out to be 0. Now this value is equals to 1, so the value turns out to be 1 itself. So this is our logical AND, and similar to the logical AND, we have something called as a logical OR. So in the OR case also, you have something called as a logical OR, and then you have something called as a binary OR. The only difference here is that the logical OR, the symbol will be the double pipe, and binary OR will be a single pipe. And if both the condition is true, then you have true. If one of the condition is true, then also it is true. If both the condition is only when both the condition is false, the output will be false itself. So if I go and change this AND icons with the OR here, right, or here, can you guys tell me what should be the output in this situation? And let's say that I go and put it here itself. Just pause the video and I want you people to tell me that what should be the output of all these 4 statements. Let's try to run this. If I go and run this, see, in this statement this is true and this is true. So this definitely will be the true. Yes, correct. In this case this is true, this is false. Sorry, this is false and this is true. Answer should be true. True. In this case this is false, this is false. Both are false and answer should be false, and it is coming as false. Now 3 and 5, how this 7 came? Now 3 is represented as 0 1 1. 5 is represented as 1 0 1. Correct? Now if I have to do a OR between them, which is represented by a single pipeline, 1 1, if I go and say that, it will be 1, 1 0 will be 1, 1 0 will be 1. So this is triple 1. And now if I go and do this, 1 into 2 to the power 0, 1 into 2 to the power 2, 1 into 2 to the power 3. Sorry, 1 and 2. So this becomes equals to 4 plus 2 plus 1 is equals to 7, and that's how the answer has come as 7. So this is how the bitwise OR and the AND operator works. Last but not the least, a very fancy operator which we use, which could kind of replace the conditional sometime, and that is called as the ternary operator. Let's try to see that, which will conclude this topic. Right, so we have something called as the ternary operators. Ternary operators. So let's say that I have something called as int a equals to 7 and int b equals to 10, and I have to go and find the minimum value out of these two. Now one of the ways is that I go and write the conditionals. If I go and say that if a is less than b, then a is smaller, otherwise b is smaller, right? In the case of ternary operator, how I go and do this, I can go and say that int min, and I'll go and say that if a is less than b, if a is less than b, and then I go and say that it should be a, otherwise it should be b. So if you go and see here this expression is called as ternary operator. This is the Boolean expression. If it is true, whatever the value is there inside this Boolean expression, if this turns out to be true, then this part will be executed. If it is false, then this second part will be executed, right? So again, this ternary operator could be very handy to write a very succinct code and might replace conditionals in certain situations. Said that, out of all these different types of the operators, right, mathematical operators, all different types of operators, they have some kind of priority order. Just like in the high school maths, you would be learning the BODMAS, where you say that the preference of multiplication is much more than the addition. Here also there is a operator precedence there, but I feel it's very tricky to go and mug that up, so I'll not suggest you people to do it. You should make a proper use of the parentheses whenever you are in the confusions to ensure that you are not messing up with the orders in which you want to apply the operators. So day 7 is concluded. We have understood operators, different types of it. Let me know in the comment that if you have understood all the things. If not, you know what you have to do. You have to always go back, watch the video again. That's the beauty of recorded content over YouTube. Keep me posted how you are cruising through this journey of mastering core Java in 30 days.